Okay, now we're going to talk about naming cycloalkanes. Notice that there are 5 carbons here in a geometric shape. That's because those carbons are all connected. Remember, when you do not see hydrogens, when it's written this way, they don't write in the hydrogens. Carbon always has 4 bonds. These are all single bonds. So 1, 2, there's 2 hydrogens out here that you're not seeing. When you are determining the name of the cycloalkanes, you are once again going to be looking for the longest chain. For our purposes, our longest chain is going to be within the geometric shape itself. So for instance, we have 1, 2, 3, 4, 5 carbons here in the longest chain. This here is not within that chain. That is considered the substituent. Notice that there's no letter out here, meaning that that's a carbon. That's a methyl group, just like we did with naming the straight names, the straight chain alkanes. Number the carbons. Okay, you're going to want to number it where alphabetically the substituents begin. So we're going to number it here. 1, 2. It doesn't matter if this is the second one is 2 or this up here is 2, because there's no substituents. Numbering really matters most when you have more than one substituent. When you only have one substituent, you don't have to really worry about the numbers. So, name the substituent in the cycloalkane. Well, methyl is the substituent. Because there's only one substituent, I'm not going to worry about putting a 1 there. I don't have to put that there if I don't, because it's already assumed that's on the first carbon. The cycloalkane, what it's referring to is, we know we have 5 carbons in a row. So ordinarily that would be pentane. Well, because they're all interconnected, it's cyclopentane. We got the other. There you go. Okay, let's do one where we do have more than one substituent. Once again, we're going to determine the longest chain. 1, 2, 3, 4, 5 carbons here. So once again, we still have pentane here. Circle and name the substituents. We have 1 here, and we have 1 here. Those are both methyl groups. Number the carbons. You're going to want to number them so that way the methyl groups have the lowest number possible. So 1, 2, 3, 4, 5. Now, granted, you could have started here, 1, 2. The numbers would have been the same, so your answer would be the same either way. And name the substituents in the cycloalkane. So, we know it's on carbons 1 and 2. Notice how, since I have more than one, I have to put the numbers there. Dimethyl, because we have 2 methyl groups, so that means that there's 2 of them. This is the substituent itself. 1 and 2 are the carbons they're on. And then the cycloalkane, we're looking at pentane again, so it's cyclopentane. I threw this one in here just to make sure that you realize that even if there's 2 cycloalkanes in the same one, this is considered a substituent now, because of the fact that this has a longer chain. So determine the longest chain. It's right here. 1, 2, 3, 4, 5, 6. 6 carbons, which give us hexane. Circle and name the substituents. We have one here. That's a methyl. Carbon here and a carbon here. That's 2 carbons. That means this is an ethyl group. This is 3 carbons. 1, 2, 3. All connected. So that means it's cyclo propyl. So instead of being propane, it's propyl. So cyclopropyl. We end it in YL, just like we did the other ones. Number the carbons. You want to give the substituents the lowest number possible, starting alphabetically. 1, because E, we're looking at E versus P versus M. Looking at the base of the word. E comes first alphabetically. So 1, 2, 3, 4. So we are looking at naming the substituents. 1 ethyl. M comes before P, so 4 methyl. Then 3 cyclopropyl. And then the actual cycloalkane itself, cyclohexane. That was a tough one. You will not be given one this tough. I just wanted you to be aware of the fact that you can have a cycloalkane as a substituent. Alright, so let's do some more practice. First thing we're going to do is find the longest chain. 1, 2, 3. So that means propyl is the longest chain. Propane is the longest chain. It's in a circle, so it's cyclo. And we have a methyl group. We only have one group, so we don't have to worry about numbering. So methyl cyclopropane. Part B. Our longest chain is 1, 2, 3, 4. So it'll be cyclobutane. This is our substituent, 2 carbons. That makes that ethyl. There's only one substituent, so we don't have to worry about numbering. So it's just ethyl cyclobutane. And then finally, 1, 2, 3, 4, 5. That's pent. That becomes pentane, all in a circle, so it's cyclopentane. Our substituent is chloro, so it becomes chlorocyclopentane. Methyl cyclopropane, ethyl group on a 4-carbon chain that's in a circle. Chlorine on a 5-carbon chain that's in a circle. Now let's reverse it and see if we can draw what the name is. We're going to basically do everything but in a reverse. So we're going to start with the chain. Bute means that there's 4 carbons in a row. 1, 2, 3, 4. On the first carbon, there's chlorine. On the 3rd carbon, there's bromine. 1, 2, 3. That means all the rest of them are hydrogens. Do a couple more. 2,2-diethyl butane. Start with the base. We're starting with butane. It's always easiest if you work backwards on these. Dimethyl, so we have 2 methyl groups on the 2nd carbons. So 2, 2, methyls. All the rest of them are going to be hydrogens. Pentane, so that means we have 5 carbons because pent means 5. 2-methyl. On the second carbon, there's a methyl group. And then all the rest of them are hydrogens. Okay, and that is all for naming alkanes. This takes a lot of practice, so make sure you're doing the practice problems on the end of each section.